Today we will prove Stokes theorem. So what is Stokes theorem? We have already discussed it. That is Stokes theorem. So in this theorem, we convert line integral into surface integral or vice versa. Means the line integral of any vector, that is A dl for closed loop, is always equal to double integral, means surface integral of curl of that vector into ds, this one, which we have already discussed, that how we convert single integral into double or double into single. In the previous article, that is Gauss divergence theorem, we have proved it that the double integral into triple and triple into double. But in Stokes theorem, in this theorem, single integral is converted into double. So this is second theorem, and that is very important. Now we will prove it by using physical meaning of curl of any vector, curl of A, that is curl of A. What is this? We know that by physical meaning of this curl of A is equal to the line integral of that vector, same vector is here, for closed path over surface area, this one. Or we may write it as A dot dl integral for closed surface, this one, is equal to curl of A into S, So this S is multiplied with this left hand side term, and this is equation. Now we may generalize this equation for n closed surfaces or n closed loops. So we consider any loop, this is any loop, closed loop, it is C, that is C closed loop. We will split this loop into number of loops, that is we may divide this loop into number of small loops like this one, in this way. So it is first loop, that would be, it is second loop, third loop, all these square or rectangles, these are basically closed loops. So there I am dividing this loop, closed loop, into number of loops C1, C2, C3, and last it may be Cn. So for the proving this equation or this Stokes theorem, we will apply this formula for number of loops one by one. So you may write this diagram, the theory of this diagram, that is, consider any loop C, that is closed loop, bigger loop, and divide this bigger loop C into number of loops, that is C1, C2, C3, C4, so on up to Cn. C1, C2, C3 up to Cn be the number of small loops comprising the total loop C. So apply this physical meaning for first loop C1. So we will get this A into dl1 or C1, here it is C1, and on the right hand side it is del cross A into S1, this is S1. Or you may write this S as ds also, ds1, you may write this S as ds. If there is small loop, then the enclosed area is also small in this circle, that is ds1, ds2, ds3 up to dsn. So I am writing ds instead of s. So this is equation for first loop. Similarly, for second loop, this will become contour C2 A dot dl2 is equal to del cross A, the curl of A, into ds2. So on. We may write for third loop, fourth loop, and fifth, sixth, and so on up to nth loop. This is Cn, and A dot dln is equal to del dot A into dsn. Okay. Now we will add all these equations, first, second, third, fourth, up to nth equation. So adding all n equations, adding all n equations, you may add on left hand side, you will get integral for closed loop 1 A dot dl1 plus integral loop 2 A dot dl2, so on, integral for closed loop n into A dot dln. And on the right hand side, del cross A is common from all the terms, from all the right hand terms, and this is del cross A is common, and the remaining part is ds1 plus ds2 up to dsn. Okay. So when we combine all the loops, this will become A dot dl for closed loop C, because on summing or adding this C1, then C2, C3, we will get ultimately closed loop C. So this is the physical meaning of this term. This addition is the whole loop is C and A dot dl. And on the right hand side, it is del dot A, del cross A, sorry, into ds1, ds2, ds3. We may write this as dsi, I varying from 1 to n, because these are the surface areas. This is ds1, ds2, ds3 means the surface area ds1 is corresponding to closed loop C1, ds2 corresponding to C2, similarly ds3 corresponding to C3, and so on up to nth. So I varying from 1 to n. So this is sigma, summation. We know that sigma and integral are same, but it is random addition or collection of the particles. In integration, it is the continuous distribution of particle. So as this ds tends to 0, with a small surface area, it will become very small, then tend to 0. Then we may write this sigma into integral. Sigma ds means sigma dsi, I varying from 1 to n. As dsi is very small, we may write this as ds, and it is for closed surface S, because when we add all these surfaces, an overall surface we will get, that is total surface, that is ds integral. So write this right hand side as this, left hand side remains same, A dot dl into of C is equal to del cross A into integral of, this is dsi means integral, double integral of ds. Okay. So I have replaced this sigma summation into integration as ds tend to 0. So this is our Gauss theorem. Actually, this theorem is already proved, but it is generalized form of the physical meaning of curl of A. So A dot dl for closed loop C is equal to del cross A. The del cross A means curl of that vector into ds. So this is Stokes theorem, or it is generalized form of physical meaning of curl of A vector. Now, the next article is the different conditions we will study what is first irrotational vector. Second one is solenoidal vector. Solenoidal vector. Third is Poisson equation, and fourth one is Laplace equation. Laplace equation. These are some special terms which we will use in our book, in our chapter. Irrotational, first one is, irrotational means which cannot rotate, because rotational means which has ability to rotate, or irrotational means the opposite of rotation, that is which cannot rotate. So we know that rotation term is connected with the curl of any vector, because curl means when there is vector which is moving in one direction, when we do the curl of this vector, then this vector become like this, means curl. Curl means rotation. So from this, the meaning of the irrotational, it is very much clear that the curl of a vector is 0. Curl of a, it means when we do the curl of any vector, then its curl is not possible. 0 means we cannot curl of that vector. We cannot not obtain the curl of the vector. It means that vector cannot become a curly, means it cannot rotate. So irrotational means the curl of any vector is 0, irrotation. And second one is solenoidal vector. It is, you know that solenoid means, solenoid is the device which you have already studied in the your classes, like this solenoid. And what is the main property of solenoidal? In case of solenoid, the magnetic field inside the solenoid is always uniform. There is uniformity, and the del of A means divergence. So what is divergence? Anything which spread in all directions like this. This is called divergence. If any vector cannot diverge, divergence of a vector is 0 means that this vector cannot diverge. It means this vector remain constant. The constant vector means, uniform vector means which cannot diverge. So means divergence of that vector is not possible. Del of A 0 means divergence of that vector is not possible. Physically, this vector cannot diverge. So if cannot diverge, then it is like the solenoid, because in case of solenoid, the magnetic field inside the solenoid is always constant, it cannot diverge. So solenoidal vector means the vector which satisfies this condition. The divergence of that vector is 0, means the vector is solenoidal. Its nature is constant or uniform, it cannot diverge. Okay. And third one is Poisson equation. The square of del square, del dot del means del square of any vector is not equal to 0. This is called Poisson equation. And if the second derivative of del means del square, if del square A is equal to 0, then it is Laplace equation. So these two equations are connected to the second order differential derivative. So del square A is not equal to 0, Poisson equation. Del square A becomes 0, it is Laplace equation. So these are the 4 conditions basically mathematically, and corresponding the physical meaning of these conditions. So we can do any numerical on the basis of these conditions. Let us do a numerical for irrotational vector. So let any r is equal to r given is equal to xi plus yj, okay, plus zk, let in my 3 dimensions. Prove that this vector, is irrotational. This vector is irrotational. How we can prove it? We can prove it by using the condition of irrotational vector. Since for the condition of irrotation vector, the curl of that vector, here it is r. So we may write this A as r. So if curl of this r becomes 0, if this condition is possible, it means the vector is irrotational. So we have to prove that the curl of this vector must be 0. So it is proof. Let us do del cross r. I am doing the curl of this vector, that is del cross r. Means del means curly upon curly xi, curly upon curly xy, j, sorry, curly upon curly z into k into r. Means cross multiply with r. R has 3 components, xi plus yj plus zk. Either you can solve by multiplying these equations, or you can solve the cross product of two vectors by using determinant, that is I, j, k. You will get same answer, I, j, k. This del means first component curly upon curly x, curly upon curly y, curly upon curly z, and third one are x, y and z. So these are 3 components of curl, del, and these are 3 components of r vector. Now you can solve it. You can solve by using simple method of determinants. So what is the answer? This is I into I curly z upon curly y minus curly y upon curly z minus j, okay, curly z upon curly x minus curly x upon curly z, and plus k, this one. So curly y upon x minus curly x upon curly y. Okay. Now here it is z, it is y. So this y and z are independent, z not dependent upon y. So it is constant with respect to y. Z is constant with respect to y. So we will get 0 minus y and z again 0, because we are doing the derivative with respect to z, but there is no z in this part. So it is constant. Y is constant with respect to z. Similarly, j 0 minus 0 plus k, yx means 0 and xy means 0. Or the answer is 0i plus 0j plus 0k, that is ultimately 0. So it is proved that this vector r is equal to xi plus yj plus zk is a rotational vector, because when we have done the curl of that vector, the curl of the vector becomes 0, means the vector is irrotational. So in this way you can do the more numericals based upon the vector of solenoidal and Poisson equation or Laplace equation. Thank you very much.